In the 2008 National Electrical Code, arc fault circuit interrupter, or AFCI, protection is mandated for all 120-volt single-phase, 15 and 20-amp branch circuits that supply outlets or devices installed within dwelling units, including dormitory units. It is important to note that the 2008 National Electrical Code does not specifically require the installation of arc fault circuit interrupters when simply replacing existing two-prong outlets. However, a crucial point to understand is that if those existing two-prong outlets are replaced with modern three-prong outlets, then AFCI protection becomes a requirement. This added protection is intended to enhance safety and minimize the risk of electrical fires. There are primarily two locations where arc fault circuit interrupters can be installed to meet the code requirement. Firstly, they can be installed directly at the panel board. This involves replacing the standard circuit breakers with AFCI circuit breakers. This approach provides protection for the entire circuit originating from that panel board. Secondly, arc fault circuit interrupters can be utilized as individual circuit breakers, and in this configuration, each circuit that requires protection is equipped with its own dedicated AFCI breaker. This method allows for more targeted protection, addressing specific circuits within the electrical system. Arc fault circuit interrupters employ a toroidal transformer as a key component of their functionality. This toroidal transformer plays a vital role in monitoring the current as it flows through the circuit. It is designed to detect any anomalies or irregularities in the current flow, which could indicate the presence of an arc fault. The toroidal transformer is essentially a ring-shaped core made of a ferromagnetic material. This core is wrapped with a coil of wire. The current-carrying conductors of the circuit pass through the center of the toroid. This arrangement creates a magnetic field within the core that is proportional to the current flowing in the circuit. The AFCI constantly monitors this magnetic field. If the current flowing in the circuit exceeds a predetermined level or exhibits characteristics indicative of an arc fault, the arc fault circuit interrupter is designed to take immediate action. It will trip, effectively opening the circuit and interrupting the flow of electricity. This rapid response is crucial in preventing electrical fires that can be caused by arcs. Arcs are essentially unintended electrical discharges that can generate intense heat and ignite nearby combustible materials. By quickly cutting off the power supply when an arc is detected, the arc fault circuit interrupter significantly reduces the risk of a fire. The installation of three-prong receptacles on a two-wire system without a grounding conductor raises safety concerns. Firstly, the lack of a grounding conductor means that there is no low impedance path for fault current to flow back to the source. This can result in a higher voltage appearing on the metal parts of appliances and equipment if a fault occurs. Secondly, without a ground, overcurrent protection devices like circuit breakers may not trip quickly enough in the event of a ground fault. This can increase the risk of electrical shock or fire. Thirdly, the use of adapters to connect three-prong plugs to two-prong receptacles is generally not recommended. These adapters may not provide a reliable ground connection and can be easily disconnected, defeating the purpose of the ground. The proper way to upgrade a two-wire system to accommodate three-prong receptacles is to install a grounding conductor. This can be done by running a new cable from the receptacle to the grounding bar in the electrical panel. Alternatively, a ground fault circuit interrupter, or GFCI, receptacle can be installed. GFCI receptacles provide protection against electrical shock by detecting imbalances in the current flowing through the circuit. The toroidal transformer is a critical component in both ground fault circuit interrupters and arc fault circuit interrupters. While both devices use toroidal transformers, they detect different types of electrical faults. A ground fault circuit interrupter detects ground faults, which occur when current leaks from a hot conductor to a grounded surface or a person. An arc fault circuit interrupter detects arc faults, which are dangerous electrical discharges that can cause fires. An arc fault circuit interrupter analyzes the waveform of the current to identify the unique signatures of arc faults. These signatures include rapid changes in current, high-frequency noise, and intermittent current drops. Arc fault circuit interrupters are designed to distinguish between normal arcing, such as that caused by a switch opening or closing, and dangerous arcing that can ignite a fire. The sensitivity of arc fault circuit interrupters is carefully calibrated to minimize nuisance tripping while still providing effective protection against arc faults. There are two main types of arc fault circuit interrupters: branch or combination arc fault circuit interrupters and outlet circuit arc fault circuit interrupters. Branch or combination arc fault circuit interrupters provide protection for the entire branch circuit, including the wiring and devices connected to it. Outlet circuit arc fault circuit interrupters provide protection only at the outlet where they are installed. Combination arc fault circuit interrupters are the most common type of arc fault circuit interrupter and provide the most comprehensive protection. The installation of arc fault circuit interrupters can help to prevent electrical fires and protect lives. It is important to follow the manufacturer's instructions and all applicable electrical codes when installing arc fault circuit interrupters. Regular testing of arc fault circuit interrupters is also recommended to ensure that they are functioning properly. This testing can be done by pressing a test button on the arc fault circuit interrupter. If the arc fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. Arc fault circuit interrupters are an important safety device that can help to protect homes and families from electrical fires. In summary, the 2008 National Electrical Code mandates AFCI protection when replacing two-prong outlets with three-prong outlets. AFCIs utilize toroidal transformers to detect arc faults. AFCIs are installed at the panel board or as individual circuit breakers. Always follow manufacturer's instructions and electrical codes.